Hello, assalamu alaikum. Can you hear me? Hello?
Yes,
Hello?
sir.
Okay, good. Thank you very much for attending the class in time. I'm going to get the snapshot first before we start the class. Okay. Now, let's come back to the point. I'm going to, as I told you already, and we agreed that going to have the class test 4 on Friday at 6:30, and this is the last class test. All of you should take it seriously, and after that I will take the best 3 class test out of 4. So you have to be very careful. This is the last opportunity to make it good if your test was not good. All right, now did I send you the result for class test 3?
No, sir.
Okay, just before going to start, I'm going to tell you that okay, just a minute. Okay, I will circulate it by email. I'll send it to you by email, but I'm just going to give you the value number. So you can just tell me one by one number before starting the class, because not a lot of people are there. So I think you can start and tell me your serial number. Can you?
Sure, I'm 1, sir. 01.
Who was that one? Means what's the name? Fardan
Ahmed
Hassan.
Fardan. Yes, sir.
Ahmed Fardan Hassan. Got 4. Next.
Sir, I'm 3.
Number 3, Asmari, right?
Yes, sir.
5.5. If you want to check the screen at the end of the class, we can see, no problem. And next. Okay, I'm just telling you it faster. Prithwaraz, what is your serial number?
21, sir.
21. 21, Prithwaraz Vishwas. You got 10 out of 10. Okay, then next, Prithwaraz Ahmed Asmari. Naim Rashid, what is your serial? Naim.
EC101 number 2.
Naim Rashid, number 2. You got 7 out of 10. Okay. Then after Naim Rashid,
Sir, me, 20.
Ruba, what? Ishti, what is your serial?
Yes, sir, 20.
20, you got 10 out of 10. Okay, thank you very much. Now next after that, Bayat Ishti. Anyone? I think Shihab Shantu, what is your serial?
So 16.
16, 1, 6, Shihab, you got 9. Okay, next Shihab Shantu, and then Tagabun. Tagabun, what is your serial?
22.
22, 22, 20. You got 5. Okay, if you want to check his script, you can check his script. Tanvir Hassan, what is your serial?
201 serial 3.
I'm sorry, serial?
3, sir. 3.
Oh, 3. Okay, you got 5 out of 10. Okay, now this is all about your marks, and you can, if you want, you can check your script, no problem. Right now, let us go for the class for today. As I told you that today we are going to go for the last class, which is the magnetic circuit air gap class. So I'm just going to ask first in the class that I'll, as you know, that I'll take the verification. Well, what I need to tell you first at the beginning, how many of you had gone through the video lecture today's air gap problem? Can you raise your hand? As you know that verification can be done, I think with the, I'll show you the screen and you have to tell. So careful about it. If you raise your hand, means you are sure that you are ready to answer to the question. Okay, so I'm going to take a snapshot. Okay, I'm going to I got a snapshot for those who are present, those who raise your hand. Just I'm reading Tanvir, Prithwaraz, Tagabun, then Ishti, Ahmed Fardan Hassan, Asmari, and Naim Rashid. As all of you have gone through the video lecture before coming. All right, it will be tested, and I hope that you can answer to the question today as well if you are have gone through that one as well. Okay, I'm not going to test today, but rather I'm going to jump to the video lecture today because it's very important class today. And as you know that in the final exam or in the class test 4 in Friday, a question may come from magnetic circuit air gap. one full question from air gap or the series parallel circuit, as you saw 7 sets sample question. Yeah.
Sir, from magnetic circuit and without air gap, two type of question will become in final step, or we just answer one question.
No,
Or you just
magnetic circuit, there are two type of question may come. One is from air gap or
Yes, sir.
from the
Yeah.
series parallel, anyone.
anyone who asks.
Or
sir,
it
what
can
is,
be
sir?
combined together. A question may come combined together. Or you can find it from the 7-set question paper, or you can get it from the assignment question, or you can get it from the practice problem. You can see this type of problems are everywhere normally. Okay, so you have to prepare for that type of problem, either series parallel or air gap problem, or sometimes it can be a combination. Then if you are familiar, you can easily answer to the question. Yeah. Any one of the question, or only one question will be coming from a magnetic circuit. Who is that?
Okay,
Tanvir
sir.
Hassan, or who is
Yes, sir,
asking?
got this.
Tanvir, okay. So I hope that you should ready for that. And this one is also very important from that point of view. So all of you just check the video link, can be accessible. Can you see the video?
Yes, sir.
Okay, now see the sound is clear or not before you go. Okay, is the sound okay?
No, sir.
Yeah, is the sound clear? Okay, just a minute.
Yes, sir. Sound is
All right.
clear. Yes.
Now let's start. Okay, just a minute. Now, can you now see the sound is clear, or oh, sorry. Hello. Hello, can you hear me?
Yes,
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 sir.
sir.
Yes, sir.
Yes, sir.
Okay, just a minute. Oh, the video cannot be seen, right? Okay. All right. Now, is it visible now? Hello. Can
Yes,
you
sir,
see?
it's visible.
Now, hear the sound is clear or not?
If say this
Yes, sir.
this
Okay, now everybody get ready to go ahead with this. Hopefully it should be okay. Now get ready to answer to the question as well. All of you. Thank you.
thing
Yeah, is the sound clear?
Yes, sir. Sound is
All right,
clear.
now let's start.
which is giving you the flavor of presence of air gap in the magnetic core. Now, in reality, you can see in the transformer or some sort of other type of core where the wire is wounded. So you can see core is having some air gap in practical field or in practical life. So if there is a air gap we can keep, it is just required to control the what do you call that, flux lines flow. So it depends on how much you want to control that, just increasing some resistance, think like that way, in series. There's the air gap, and without any payment, you are not going to pay anything, you are just cutting the thing and you are just going to adjust it with the air. So it is not like a different type of core you are going to use here. You are just cutting a part of the core and make a air, so that you are adding some reluctance, and then you can control the, like in series you are going to add some reluctance. So this is the main target of air gap. Now let's come back to the point. If air gap is present, it is the same thing. You can imagine air gap is present means another core is present inside the gap. So what will happen then, the two core will be in series, and you have to draw in series like that. But what is the difference between this? That is what we're going to talk now. If it is air gap, and if the current is flowing through the winding through the, and if the number of turn is n, if you think like that, then I and n is the magnetic force applied, and the phi is produced. This is the phi produced over here, and the flux lines is going through the core. And how the flux lines are going through the core is this way. You know that already, I told. And this way it comes, and then go. So this is the flux lines is going to produce and flow. What happened in the case of air gap, over here also, some over the air gap here, over here also the air flux lines will be flowing through this path. I mean through the, okay, I'm going to go the green line. So over here also the flux lines is going through, but it is the same flux lines going through that. Now if this one you can say that is a phi g, this is phi g, and the flux flow through this is phi core, and or I can write here phi core. So this phi core and phi g, it is the same flux lines flowing through, like a current electron flow. So how much electron is flowing through the core, so that is the same number of phi g will be flowing through that, because again it have to constitute another phi core. So phi core is enter into the air gap and then out from the air gap, and again it is phi core. So phi core and phi g must be same in that case. So you can say that a phi core which is coming through the core will be nothing but equal to phi g, that is going through the air gap. And you understand it, because the number of flux lines flowing through the core, if you go through a three-dimensional graph.
Okay, left class people, can you hear me? Phi is coming
Yes, sir.
out, so the phi g what you're getting is same. But there's a question here. Question is, there are two types of flux actually is out from here. Two types, having two types of effect. One is the flux produced here because of the n into I, the electromagnetic force actually produce the flux. That flux actually, one flux actually from here where it is produced, that goes this way. Actually, I'm going to show you here. That goes this way and coming in it. That means some of the flux lines going out like this and going like that. This type of flux lines which is going out, and also this side also same, in and going out like this, and then this some of the flux lines will go out through this and coming in back like that. That is called, okay, lab class people, I hope that you can hear me, right? Hello.
Yes, sir.
Okay. Can anybody tell me what is the name of this type of flux, which is some of the flux is going out and coming in? This is a coil, you understand, the coil is there, right? The coil is there over here. The coil is wounded like this, and the oil is The coil is there, the coil is moving, and then it's coming like that. The current I is flowing and the current going out. Because of the current, flux lines is produced at, then flux line is going through these main flux lines. But there are some flux which is going out from the coil in the side line and enter, side line and enter. What is the name of this type of flux lines? Can anybody tell me? Yeah, I think I'm asking, okay, better I call the name of the students. Okay, just a minute. Yep. Here we go. Ahmed Fardan Hassan, can you answer the question? If you cannot, then it's all right. You can just tell me, sir, no.
Sir, no, sir.
Okay, good. Just that's it. You don't need to answer because I think raise your hand better because of this question is a very much outside question, not in the video lecture. So maybe some of you cannot answer. Okay, Pythagoras, Vishwas, what do you think? What is the answer?
Sir, magnetic flux.
Magnetic flux. Magnetic flux is the flux which is produced by this coil current and it produces and then it goes through, which is phi core, and there are some more magnetic flux which are going out into the air and come back around the coil on the left and right side. So these magnetic flux lines are not in use, is not going through the core. The blue flux lines are just out and coming in. That's the outside, that means within the air. But the black, the what do you call that, the black flux lines, that is the magnetic flux lines we are considering, that is phi core. The magnetic flux which is going through the core, the black one, is a huge, and some few flux lines are the blue, which is out and it goes through the air. This number is very, very less than compared to the main magnetic flux. Okay, I think Pythagoras, what is that? Oh, both cases. There's another fellow who raised hand. Is it Pythagoras? Okay, Rubayat, what do you think, Ishti?
Yes, sir. It is magnetic flux.
Yeah, it is magnetic flux. Phi core, the black one is also magnetic flux. Blue one also magnetic flux. The blue flux actually it is going into the air. I think all of you get this information. This is called a leakage flux. That means this is a leakage flux, leak from this into the air and come back, which is not going through the core, even though it is very small amount leaking. So this information is just for your information, actually. What is leakage flux? So that you can understand the definition of leakage flux. Thank you. Actually, flux leakage. So some of the flux will be leakage, but this is very much a negligible amount, we can see. So, but that phi is called phi L. So that the total phi produced, some of the flux lines is going to be leakage and the rest of the flux is going through the core. And that leakage flux is very small amount, but there is some. In ideal case, we are assume not this thing to be affecting here. In ideal case, we think there is no phi L, only the phi core is considered. That's why this is one of the assumptions I'm telling here. Another assumption is here. In the air gap side, actually, you know that the flux lines are coming down. All it's a projection. It's a square. It's a shower of the. You leave the shower, the water is falling from the shower like that. All the flux lines are falling, and it's a square projection. You can think all the shower, but in reality, what happened? In reality, you can see the thing. Some of the flux at the outer side is just like a hump. It is going blur something like this and going back. So a little bit like a balloon type actually. So it is like a balloon type going out, a little bit going out and then coming in back and then. So the full projection is not exactly square. It is something like that. You understand? I hope that is something like this, and like that. Straight away. So a little bit outside of the flux lines is going and coming back to the wave. That is okay, but it is a little bit blur here like that. This way, like that. So what happened in this case? This is the thing. What this thing happened. This is known as fringing flux. You know, fringing flux. Fring, uh, fringing flux. So that one is a leakage flux, and this is your fringing flux. And this fringing flux actually having some fringing effect. And what is that effect? We're going to say because of this fringing flux, actually the area here will be not exactly the area of the core area. It will be a little bit different area. So in this case, the different area AG in this case will be a little bit different. In the core area, okay, okay, let's go and listen. If it is AC, the core area is AC, then if it is a blur, like a hump, like something, or if you can see the area over here, AG. So I'm just asking leftmost people now, I'm asking the question here. All of you understand what is fringing flux effect? The fringing flux affecting the cross-section area in the air gap. Now, who can answer this? Core area AC is the normal core area, and AG is the air gap area. I think you have well understood. Now, if you consider the fringing flux effect, then the air gap area and the core area, AG and AC, what is the difference between these two? Can you tell me? Raise your hand. Okay, the difference, I mean, is this AC and AG are same like what you have seen in the video? Will it be same, the AG and AC, if we consider the fringing area, the fringing flux area? Will it be same AG and AC? Raise your hand.
No,
Hey,
sir.
okay, who said no?
The Tagabun.
Tagabun. Okay, Tagabun, you know the professional way. I told raise your hand and then answer, right? And you just given me the answer directly. But
Sorry, sir.
anyway, it's all right. Anyway, you can answer this question first and then Ahmed Fardan can go. Okay, you said no, it is not same. But in the video lecture you saw it is same, right, Tagabun?
Yes, sir.
Okay, now it is not same, you said, if we consider the fringing flux. These two assumption actually for your information in this video lecture, or I'm adding because of you need this knowledge about the magnetic circuit. That's why when you come in your future life, some some upper classes, upper courses, when you're going, somebody will ask you, the lecturer, what is fringing flux and what is leakage flux, and you say, I don't know. That's the information I'm giving you here in this slide. Okay, I hope that now you can understand it. What is leakage flux? Now go at the, can you tell me, it is not same, you said. Fine. Now AG and AC, which one will be greater?
Sir, AC.
Okay, AC will be greater than AG. That is what you are saying, right? That means this is then AC is greater than AG. Now, okay, now I'm just telling Ahmed Fardin, you raise your hand. Do you agree with her?
No, sir. AC is equals to AG.
AC is equal to AG. That means you're saying they are same actually.
Yes, sir.
Okay, are there anyone here who can answer? Who wants to answer all? Yeah, who's that? Pythagoras. Okay, Pythagoras, tell me, what is your idea?
Sir, AG will be greater than AC.
Because sir, AG is not equal to AC, AC is not equal, is not more than AG. So only last thing is AG is greater than AC. That's why you said, right? Pythagoras.
No, sir. Like, so because of the fringing flux, I guess it means that the flux lines are gonna spread out.
Right, good. Your answer is absolutely correct, but I cannot give you the marks because that is the only answer left, right? And you told it. Your explanation is absolutely correct. So I'm not giving marks to any of you because Tagabun is also correct from her answer that it is not same. I think better I can give some honorable marks to both of you, Tagabun and but 0.01, not 0.1. Okay, now let's come here. Tagabun, what is your serial number?
22.
Okay, I'm giving you 0.05 because your answer partially correct. And what do you call that? Pithwara is also correct, but he got the answer after giving 50% answer. So I'm giving both of you 0.5, 0.05, 0.05. Good. You are absolutely correct with your explanation. I'm talking to Pithwaras. Absolutely great, and it is correct that the AG is greater than AC because of the fringing flux actually spreading in such a way so that the cross-section area here will be more. It's more area will be there in the air gap because of fringing. Now this fringing effect actually make it unequal, but further said it is supposed to be equal. That is in ideal case where we can omit the fringing flux as well. We are omitting this thing. This is assumption number 2, and we are omitting the leakage flux assumption. These are the 2 assumptions we are consider and make it ideal case. I think all of you got the point. Now we are going to go to the main derivation. Let's go. At least one person can tell me if this is your AG, then what happened? Which cross-section area will be greater? Area phi SC and phi G, are they same or different? That's the first question we have to go. Now I'm asking the question to someone and he has to answer to. Now I think again this time no raise hand. It is very okay. You can drop your hand, please. Okay, I think I'm going to call the name and you can understand and see this. If we consider this fringing area, then you have to tell me, will it be, Masha, are you there?
Yes, sir.
You get my point what I'm talking. If we consider the fringing effect, fringing flux, if we consider, then the flux in the air gap is phi G as you see, and flux in the core is phi C. Then phi G and phi C, will it be same? Masha, you got my point?
Yes, sir.
So what do you think? That means if we do not consider fringing effect, it was phi C and phi G was same. Now, if we consider fringing effect, if we consider, then will it be same or different?
Different, sir.
You said that the number of flux will be increased in the air. So
Yes.
if the core, if the number of lines coming from the source is 100 lines, then when it goes through the air gap, it will be more than 100.
Sir, I'm not sure.
Why not sure? These 2 materials are in series or parallel, the air gap and this thing.
The series.
If series, then the current will be increased suddenly in this other resistance.
No, sir.
So what do you think?
Sir, it will be the same.
So why you don't get it? It is just spreaded. It doesn't mean, and because of spreading, actually it is affecting the area. Area is increased, right? But the total number of electron flow, total number of flux lines will be same. You understand it?
Yes, sir.
I'll give you 0.1 if you can answer the final answer. If this is same, then what is the equation for B? Let's say I'm finding BG. BG will be what? You cannot answer the question. You don't know the definition of B, right? Masha, can you tell me the definition
No,
of?
sir.
Why not? B definition you have started, right? Okay, in that case, I cannot give the marks because this is a general thing. Rupkotha, are you there? Absent. Okay, Rupkotha is absent. Now, Tashfiqur Rahman, are you there?
Yes, sir.
Oh, he's sleeping.
No,
So
sir.
what do you think? B equal to what?
Sir, BG.
Yeah, BG equal to what?
The BG equals to B core.
I'm talking about the definition of flux density.
The definition of flux density.
Yeah, B equal to what?
Oh, BG equals to mu into H.
Okay, mu into H. Definition means what? Can you tell me definition? The flux density is the flux
Magnetic,
per
magnetic to the iron core. Magnetic
No.
flux to the iron core.
right. At the first lecture, first definition. Can you check that? It is written there, the B equal to what? The magnetic flux density. First lecture note, the first topic.
So that is phi by area.
So what are you talking then? This is the basic definition. Magnetic circuit you have studied in 101, and next semester 201 you go and Shabnam asks you what is magnetic density, and you tell these, that, all garbage thing, the basic thing you don't tell. What are you talking? Are you okay? These people are
Okay,
not
phi by
very much wondered about it. Okay, now let's come back to this. Phi g equal, BG equal to what?
Phi by area.
What is phi?
Phi
Where
by
do you get
A.
phi?
So it is the
BG
magnetic
means
field lines.
phi g. Okay, BG means the magnetic flux of the air gap. Air gap means it should be phi or phi g. Phi means what? Phi, there are two things. One is a phi core,
Phi
one is a
g.
phi g. Where you get phi from? You didn't see the video lecture, so that's the main problem. Anyway, phi g divided by what?
Area.
A.
A.
Now what is that? A, have you found A here anywhere?
So AG.
Right, careful. Okay, now you tell me, what about the B core? That's the two things, right?
Yes, sir.
BC will be what?
This will be Q core divided by A core.
Q, where you
Phi,
get
phi
Q?
core divided by A core.
Okay, fine, phi core. You said Q, are you okay?
Sorry,
Where do
sir.
you
Sorry.
careful about it?
Phi,
Okay.
phi core divided by A core.
Okay, A core, right, good. Now, as Tagabun said, that this phi core and the phi g, what are they? Same or less and more?
So they're same.
Because even though fringing flux is there, doesn't matter, just the phi g, and because they are in series, and the series means same current, means same flux lines. So phi g and phi core is same. You clear?
Yes. Yes.
If it is so, then BC and BG, they are equal also or not?
So they are equals.
Okay, they will be equal if AC and AG
Are
are
equal.
equal. But is AC and AG equal if fringing flux we consider?
AC and AG, yes, sir.
Just now you arrived or you heard it?
Well,
What
if fringing flux is, it's not equal. If fringing flux is considered.
then you tell me BC and BG, which one will be greater or smaller?
So BC will be greater.
Okay, if AG is great, AG is what? AG and BC? AG is AC? You said BC is greater than BG.
Yes, sir.
Okay, now you tell me how you said BC is greater than BG. Phi C and phi G is same. AC and AG, which one is greater?
So AG.
If AG is greater than AC, then BC will be greater than BG. From
BG.
that point, you tell me, because of yeah, you're right. So basic AC is smaller, means the BC is higher,
Yes.
and so vice versa. That is the reason why BC is then BG. Okay, this is what we understand from the fringing flux effect. That means if we consider the fringing flux, then this will not be equal, rather this will be this. So this is another assumption we have, assumption number 2, that we assume there is no fringing flux in an ideal case. Also, there is no leakage flux in ideal case, which is assumption number 1. This is assumption number 2. If we consider these things are present, then we cannot say BC and BG equal. But why we say? Because the effect is very small. The AG is greater than AC. That AG is greater than AC is very 0.1% greater or something like that. So it is very much negligible, and that's why assumption is it is equal, and that's why BC and BG is equal. That's what in the whole lecture you heard. Actually, we have told that there is no leakage path, there is no fringing effect, and then we have gone to the main issue. That means our main derivation. You can listen. For the cross section area different, then which one will be bigger, AC or
G by A
we are assuming negligible for the time being in the ideal case. So we are assuming that these are absent. Okay, if they are absent, then the AG and AC will be same. There is no difference between AG and AC. So phi C, phi G same, AG, AC same. So BG, BC will be same. That one we are going to see from this lecture today. Let's go and see.
Like this, and then you can see this one coming like that, for example. Then what will happen, you can see all the flux lines are passing through this flowing, just like a shower, you know, the rain through the what you call it, through a pillar, through the pillar, so all the flux lines are coming from the top to the bottom, just like shower. Right, it is going through like this. So it is just like a shower flowing through the top to the bottom. And so you can just cut the thing here. If you cut the thing here, area of the air gap, and that the shower, the flux lines are flowing, that area also you can see is something like a square area where the flux lines are going through. And the area of cross section here will be also AG for the flux line. And if you cut the core anywhere, because it is throughout same, if you cut the core anywhere, and the core area, if you find a core area over here, you can see the same core area as well. The air gap cross-sectional area through which the flux lines are falling from the top to the bottom. Okay, this two area also same. Now, if this two area cross-section area, that cross-section area are same, then flux lines are same, then we can say for the core, we can say the core flux density B core will be what? B core and AG is same. Phi core and phi G AG is same. Then we can conclude from there that B core and I'm sorry, B core and air gap flux lines are same, core area and flux lines area, cross section area are same. So we can say B core equal to BG. Now my question here to you all, same way shall I say the same thing, that H core, the magnetizing force for the core, will it be equal to Hg or not? That is a question now. All are same.
Okay, live class people, now is your turn to answer to the question. Shahrukh Islam. Okay, I asked the question to whom just now? Is it Tashfiqur Rahman? Hello?
Yes, sir.
I asked you this question. I asked you question, not yet.
You asked me about the fringing effect, sir. B courage and
Oh, that one you answered, Tashfiq.
yes, yes, sir.
Okay, good. Now, next question to Afnan Rubayat Kabir. Are you there? Absent. Okay. Then Ishti, are you there?
Yes, sir.
Okay. What do you think about it? Actually, the H core and HG is same.
No,
If
sir.
everything is same? No.
No, sir.
It is not same because tell me why it is not same, because the BG HG comes from BG, right?
Yes, sir.
What is the way?
Sir, it would be mu naught AG.
So HG will be equal to what?
Sir, BG by mu naught.
BG by mu naught. Good. So this is BG by mu naught. This is the way the HG will come. That is the equation you already know. So from the equation, and mu naught is what? Do you know the value?
Yes, sir. 4 pi into 10 to the power minus 7.
Okay, mu naught is fixed, which you already know, that 4 pi into 10 to the power minus 7. So from that relationship, you can find the value of HG. And
Yes, sir.
the B core to H core, this will come from also the same relationship, B equal to mu B equal to mu, what you call mu H core? Is this something like that?
No, sir.
I'm not asking you this question. Your question is done. Okay, now I'm asking to Shantu, are you there? Shihab Shahriya Shantu.
Sir, I didn't watch the lecture videos.
So you cannot answer. Good.
Yes, sir.
That's straightforward. No wasting time. Julkan 9 is absent. Okay. Then who's the next person? Sophia is absent. Okay. Then Sabbir Ahmed Shantu absent. Then Jawad bin absent. Okay. And then Sumaya absent. Okay. Then Fardin Ahmed, are you present? Fardin? Absent. Then Shahiduddin Babu absent. Okay. Then Iftikhar Ubaid Arnab.
Yes, sir.
Okay. Can you answer this question? He said SG will be obtained from here and his score will be obtained from what?
Sir,
From
I
B
didn't
core.
watch the video, sir.
But you understand from that H should be got from B, right? This H core should get from B core. What is the way? Is it through the relationship B equal to mu H? No idea.
No, sir.
Okay. Why you didn't go through the video lecture? Okay, now Mudassir Billah, are you there? Okay, then Arif Hussain. Okay, then Sheikh Sadi. Sheikh Sadi absent. Okay, then Rahela absent. Okay, then Azmeri, are you there? Hello, Azmeri.
Yes, sir.
Yeah, can you answer?
No, sir.
This H should obtain from B. Last class we saw how to get the magnetizing force from B, Tesla. Okay, you cannot answer, no problem. And then Muhammad Faikadar, are you there? Absent. Okay, Ahmed Fardan Hassan, are you there? I
Yes,
think
sir.
you are there. Okay, can you answer this question?
Yes, sir. It will come from the BH curve.
It will come from the BH curve. Very pathetic thing that this answer you could not give actually, because this is the very basic. And I have sent you the BH curve by email a couple of days ago. And I told you to use of BH curve. What is the reason for BH curve and how to use? This is the one of the application of BH curve, that to get the H from B or B from B to H, either B to H or H to B, it should come through the BH curve. If it is not the air gap, but only the air gap case, it will be using the equation, the B equal to mu H, because this is considered as a linear. Air never go for saturation, but other materials go saturation. That's why they have that separate curve. All right, I hope that it is absolutely correct answer. Let us go. Oh, I'm sorry, just a minute. Okay. Are you there?
Between AH core and BC.
No, I'm asking you.
Yes, sir. BH curve, sir. Yes.
What curve?
Find
Okay,
BG, sir.
Good.
Yes, sir.
So you should get the BG as G equation,
mu
or
naught.
this one.
Yes, sir.
One
This equation
gives
Sorry,
you the Hg.
Yes, sir.
So the Hg you are getting from this equation, because in the BH curve equal in that case.
Yes.
If this is equal, you say from this equation. So this Hg and H4
Yes, sir.
cannot be equal. Even these two can be equal, because you saw the equation as so far. That this is the reason why they are not equal. Good. This is the answer to this question. All of you understand, I hope. Now let's have a look and see.
Same, but what happened to the magnetizing force? Is it also same? If you were asked this question, we are going to find from the BG. Okay, this is the way. And if I ask you, the H core should be found from B core, how? You already saw lecture 1 be equal. Now, a question is how to get the Hg from BG. That's what the Hg you can.
As you also absent.
read it, all of you can get a snapshot of this thing. Okay, if you read it, what is the question said? Find the magnetic flux. All of you please keep ready with your calculator because you have to do a lot of calculation today, and all of you have to answer if you want to get a bonus point, and you know that, so that it will help. Flux. This is what is the thing you have to determine. Magnetic flux means phi. The phi equal to what? So there is a question here. Find phi equal to what? So far, if you see, phi was given most of the problem, and you found from phi divided by a, you got the b, and you solve the problem from h and ting tang. But this time it is an opposite thing happened. It is what you have to find is the phi. So what is the phi in the circuit if the 4 ampere current is applied to a coil of a magnetic core where there is number of turn is n 100 turn, that a magnetic motive force is applied.
Now the Laplace people, you have to find the phi for the series magnetic circuit shown below. For the what specified, what is this, Shibli?
Yes, sir.
Okay, can you answer to this question?
Sir,
What is written here? You cannot, you don't know how to read, write English? Apply, it will be Ni, it will be the impressed MMF, which is, if you multiply them, you get 400, right?
Yes, sir.
400 what? What is the unit?
Sir, ampere turn meter.
Ampere turn meter, ampere turn only, that's it. Ampere into turn, ampere turn. Okay, so this is 400 ampere turn is the magnetomotive force you already impressed to the circuit, that is told here. Good, that's the answer to this question, very simple. All right, now let's come back to the point.
4 into 100 is a 400. So 400 magnetomotive force MMF is applied, 400, 4 into 100, applied on the core, and what will happen? Through the core there will be a phi produced, and that flux lines will flow through the core. And question is, what is that phi? It's a very straightforward question, you can understand. If you apply the MMF 4 into 100, that is 400. It's a MMF is what? Ni, you remember, Ni. So which is 400. If you apply the 400 here, what will be the phi produced? That is the question you have to answer. Clear? Hey, all of you dead or are different, remember. So the length of the core is, if I take the blue one, the length of the core is from here, from this point to go up to this point. So from here to there, without air gap, remember, L core is without air gap. But when the air gap is coming, this very small part air gap, a very small part air gap, and that one is given here as 0.01. This is the air gap for this, and this is the L core for this. Okay, so I hope that you understand these two lengths are different. If the total core length, if you consider the L core plus air gap. So sometimes question comes, the total, like you have 2 pi r, the radius of the circle is given. So what will be the peripheral? Peripheral will be 2 pi r. 2 pi r minus 0.01 is the L core. Sometimes L core will not be given directly. Maybe you have to calculate it from there. So that sort of things can be happened also. So you need to understand what is L core means. L core means without the air gap. So if you have the radius given of the circle, then you have to find the.
Nusaiba Khan, are you present? No. Okay, just look at the whiteboard. Can you?
Yes, sir.
Okay, this is the question. Okay, the Laplace people, today's Laplace people, I'm going to talk to Ishti. Are you there, Ishti?
Yes, sir.
You answer to this question. What will be the LC in this case?
L core.
Have you,
Sir,
yeah.
L core will be, sir.
You are having
calculating.
the, listen, you are having the calculator.
Yes, sir.
Go and tell me the answer. All of you, please do it and check whether this is correct or not.
Sir, L core would be 0.31
Okay,
or
tell me the equation, please.
Sir, 2 pi r minus 0.005.
2 pi, not in here, 2 into, right? 2 into pi
Yes.
means what? Pi value 3.14 into
0.05
r is 0.05.
Yes, sir.
0.05. Okay, good. Then what?
Minus
Minus
0.005.
0.05, like this, right?
Yes, sir.
Equal to what?
Equal to, sir, 0.309.
0.309. Is it correct what he said, everybody?
Correct, sir.
Yes, sir.
Good. I think this is the way to find the value. Let's go. If the radius of the core is given 0.05 and the gap for the air gap is given this value and the radius of the core is given this. Now, what is the core length? How can you calculate and what is that? Can you tell?
2 pi r এটা থেকে আমরা
This value first time. 2 pi r is what? Okay, the answer is correct. We can see from here. Let's go.
First thing solution is you have to draw the what? Electrical equivalent circuit. I told you in the magnetic circuit problem, first job is to draw the electrical equivalent circuit. So I'm going to tell you once again the things given here. You have to write like this, maybe better. Given here, the area of cross section. To plot it, then your solution will be coming.
So all of you can see what are the things given here. From this, you have written that it's written that SC is given, LC, LG, and number of turn and the current flow through this. Now, from all this information, you have to find the value of phi. This is a bit critical problem. Let us see.
FG. These are the three magnetic force you are going to see here. So if you want to plot it, then your solution will be coming like that.
Okay.
F is equal to Ni. N is equal to
yeah,
and I is equal.
FC is what?
Yes. Sir, FC
C and LG are known. And
yes,
which are unknown?
sir, unknown is HC and HG.
HC and
HC and HG.
okay, HC and HG unknown and other two.
Yes, sir.
Okay, these things is known. Yeah, this thing is known. What is the value of LC?
LC is 0.16, sir.
And what is the value of LG?
0.001, sir.
Okay, let's go and see you are right or not. You said like that, something like this, right? Right. So you
Yes, sir,
need
yes.
to know the HC and HG. Now this HC and HG, how many equation here and how many unknown?
Sir, এখানে স্যার দুইটা unknown আছে স্যার
And how many
আর দুইটা
equation?
known.
Hey, how many equation?
Sir, two equations, sir.
What are the two equations? Tell me.
Sir, H, sir, equation করব স্যার.
Now you said there are two equations here, right?
Yes, sir. Yes, sir.
Where? Can you tell me where are the two equations in the whiteboard?
Sir, Ni is equal to Hg Lg.
This one. This one
Yes,
means
sir,
this
yes.
one.
Yes, sir.
That means one equation here. Where is the other
Yes,
equation?
sir. Sir, other is equation, sir. Sir, এখানে sir Hg.
Okay, live class people, I'm just asking the question to Mahmoud Kamrujaman Mim. Mim, are you there? Mim is absent, okay. And then going to ask Naim Rashid, I think you are there, Naim?
Yes, sir.
Can you answer to this question? What do you think actually? How many equations there?
So there's one equation and two unknowns.
So what to do?
So we cannot solve it without another equation. So
Right. In that case, yeah, that's right. In that case, since we do not have another equation, we have only one KCL, one loop, one equation, so two unknown. If something like that, then what to do?
So we
Have
have
you
to,
gone through the video lecture? Yeah.
yes, sir. We have to make an assumption that all the magnetomotive force
No, that's all
goes
right.
to
I think
the
what is the
air gap.
purpose? You have to do what? For purpose is what?
So to find HG and HC.
Yep. So you have to make a trade-off. You have to make a
Yes.
optimization between these two.
We
Means
have
you
to
have to
pick
make a
particular
trade-off.
values. Yes.
Trade-off means what value of SG and SC can make the can satisfy the equation. That means you have to find the value of SG and SC trade-off value between these two so that it can satisfy the equation. So whatever the two values you're putting here, their multiplication together gives you equal to 400, like that sort of thing. So the little bit trial and error method you have to apply here. You get my point? You assume one, yes, and then try whether the equation is satisfied or not, like that. As soon as the equation is satisfied, then these two values HC and LG for which the equation is satisfied, that is the value for HC and HG. You got it now?
Yes, sir.
Yeah, that's the way we have to find. But from the value of HC and HG, which satisfy this equation, that is the correct value of HG and HC. From that HG and HC, you can find the value of phi, and that will be the required phi for our case. Good. Now let's go.
Sir,
From this circuit, you get another equation.
Sir,
one loop, one equation you get, right?
Two, sir.
Two, because two unknown from one equation. That's what you have to do. You have to do some trial and error method, some sort of optimization or some trade-off between the SC and SG you have to do here. That is the technique to solve this problem, and we are going to see how to solve the problem. Okay, let us see.
Yes, sir.
Okay.
If you know what is the SG value, and means you can get the value of B and phi, and for there are how many unknown here in this case? What is your idea? How many unknown?
No.
No, you can no, because phi you already know that phi equal to what means? Phi equal to means what? Phi means phi c phi g, same. Phi c phi g equal to what? Same thing. So phi g and phi c is not given. That's what you have to determine. So you cannot find the bg and bc from here because you don't know the phi c and phi g, and that's why hc and hg you cannot find. That's what I'm talking about. This hg and hc are unknown. That's why I put the two close to question mark here. Just I'm talking about. Try to understand my point. Two unknown, one equation, H curve, and then you can find the phi c from BC by BC into A. You can easily find the HC, and your answer is done. Or if you can find the value of HG here, then HG can give you the value of BG by throw mu 0. So multiply by 4 pi 10 to the power minus 7. And if you get BG, then BG can give you the phi g. Phi g means your destination is done. So you cannot find HG, you cannot find HC. None of them you can find from this equation. Because why? Because 3x plus or not. If the equation is satisfied, going to value an error method. That means we substitute the value of HC and another value HG, and we see this left hand side and the right hand side are becoming equal or not. Got my point? You are going to put every time different value, and then you get the you see the equation is satisfied or not. If the equation is satisfied, that value is the value for HC and HG with a standard method, with a standard way in order to solve this problem. This trial and error method we have to apply. It is not necessary. If you say 100, 400, it is 100% accurate result, but it is not necessary for this question because it's not possible for human trial error determination. Now, if you look at the question carefully, all of you, what is written here? Can you see? Can anybody read what is written here? Determination. Now, if you look at the question carefully, all of you, what is written here? Can you see? Can anybody read what is written here? Yeah, this line under the, what is that written there? Anybody? The orange line. You are going to find the phi value. That phi will be tolerated if the result plus minus 5%, if the result is within plus minus 5% error. That means this difference should be within plus minus 5%. That means if the value is 395 or if the value is 404, then you have to check, yeah, it is within plus minus 5% or not. Let's say this is 400, this is not this, not this, it is 500. Okay, if it is 400 and it's a 500, do you think the...
Okay, now let us understand. I mean 0% error. Now, if the
Yes,
right
sir.
hand, what is that?
Sir, it will be 1.25%.
1.25 is a plus or minus?
Sir, plus.
Kill yourself again.
No,
Left
no,
hand
no,
side-
sir. It is minus 1.25.
Okay, if it is 404, then what is the percentage?
Sir, then it will be, sir, 1%.
Okay, if it is 500, okay, if 1%, 1% you said, plus or minus?
Sir, if it is 404, then, sir, it will be, sir, minus.
And 395 also minus.
Yes. No, sir, the 404 will be plus 1 and the 395 will be, sir, minus 1.25%.
And 500?
Sir, the 500 will be,
Okay, I'm telling, I think lab class people understood actually what is going on, and you all understand hopefully. Naim Rashid, you already answered the question. Now, Tanvir, are you there?
Yes, sir.
Okay, you tell me what will be the percentage if it is 500 and compare with the 400.
So 500 minus 400 divided by 500 into 100.
What is that percentage coming there?
Sorry, it will be 500 minus. Sorry, it will be 20%.
20%. Is it within plus minus 5% or not?
Plus 5 then outside of the range, sir.
Outside of the range. So this cannot be acceptable. The acceptable range is 5%. So like that, so that the difference should be such that it will be within plus minus 5%. Then answer is acceptable answer. Through this trial and error method, you have to check every time whether the difference is within plus minus 5% or not. If it is outside, then you have to go for another trial by changing the parameters. But if it is within plus minus 5%, then you can straight away jump to the answer that yes, we got the answer, and you finish your trial and error method and you get full marks. I think let us see how to go.
it is not in the tolerance.
So first thing what you have to do, this is the first step you have to do. Let all the MMF applied on the air gap. On the air gap. Applied on the air gap. If you assume that, that means your MMF, all the MMF is what? All the MMF is NI, this is 400. All the 400 is applied to the FG. So in that case, we can write this FG, F will be equal to FG That means your Ni, all the Ni is applied on the FG mean HG, LG. No core. If it is as assume first, then from here you can find that N into I is 400 and HG you have to find and LG is 0.001. So going to get, if it is assumed that first initially all are applied here, if this is the scenario, then HG is going to give you the BG, and a BG.
Okay, raise your hand who can answer to this question. I asked all the question. I asked question to everybody. Now open question.
Sir,
Okay,
you didn't ask me.
what is your name?
Sir, you didn't ask me also.
Okay, can you please first one? What's your name?
Sir, Prithvi.
Serial number?
21.
21. Pythagoras. Pythagoras, I asked you, but you got 0.05. What is that for? Oh, the
Sir.
open question. Okay. Now, yeah, you can go ahead, Pythagoras. Now, how to get BG here? Bit faster.
Sir, mu naught Hg.
Tell me the value.
4 pi into 10 to the power minus 7 into 4 into 10 to the power 5. It will be 0.5 Tesla.
Okay, 0.5 Tesla you get BG. What will be the next step? We should get what from here? BG to?
BG is equals to BC.
BC equal to BC. So after getting BC, our target is to find what?
Sir, HC.
HC. What is the HC?
So we are going to get the HC from the pH curve, and that will be 1500 ampere turns per meter.
Okay. And after getting that 1500 ampere turn meter, the HC, then we are getting HC and HG or this value, and HC is that value. What do you do with this HC and HG value?
Sir, we like compare it with like see if it's with like first we get the phi c and then we see if it lies within the percentage given to us.
Okay, that means you are going to say that you are going to substitute the HC and HG in this equation and you compare it, right? So what is HC?
HC is 1500.
Good. And HG is?
400,000.
Okay, look at it, 400,000. 400,000. Okay, 400,000. Yep. So if you substitute this value, then you have to check what is this is equal. After substituting these two value, you have to calculate and then see that it is equal to 400 or not, right?
Yes, sir.
So what is your video lecture told you?
It's 640.
640. What is the percentage?
37.5%.
Okay, let's go. Okay. Substitute 6.640, you said. Then 400 and 640, if difference is a percentage error coming here. What is that you said?
37.5%.
37.5%. Good. I think Pythagoras had gone through the video lecture. Good. And this is what you understood. And who is the guy actually told I didn't ask question? Can you
Tagabun.
Tagabun. What is your serial number?
22.
Okay. Now Tagabun can answer to the next question. If 37.5% is the error there, then what we supposed to do with this?
Sir, it is outside of the tolerance limit, so we can't take 640. We have to reduce phi c again.
What is the phi c value?
Sir, phi c value previously was 1.5 into 10 to the power minus 3. Now we can reduce by some percentage, like it was 37.5, so we can reduce it by 30%.
Okay, you said it is 1.5 into 10
Yes,
to the
sir.
power minus 3.
Yes, sir.
So we have to reduce the phi in order to reduce what do you call that?
Phi c.
So pi c is not the answer here, right? This phi is not the answer.
Yes, sir.
Because it is not satisfied. So we have to reduce by 37.5%, as your Pythagoras was saying. In order to reduce 37.5%, we have to, as you said, we have to reduce the phi, this phi, or
Yes.
phi c, whatever you said. By how many percentage we are going to reduce?
Sir, 30%.
Okay, we can assume 30%. If you 30%, then what will be the value coming? 30% of this is what?
Sir, 1.5 into 10 to the power minus 3 into 0.7. And the answer is 1.05 into 10 to the power minus 3.
Okay, in the next slide, maybe you can go. 37% is
1.05 into 10 to the power minus 3.
Okay, that is 0.7. You are multiplying.
Yes. Yes,
okay,
sir.
and then you are getting 1.05. Now, what do you do with this 5? New 5.
Sir, again, we will find BC new, and from BC new,
how is BC new equal to?
sir, phi C new divided by area.
Good. The basic definition, phi C new divided by area. Okay, phi C new is this one, and
Yes,
area is this. What is the value coming there for?
Sir, now value 0.35 Tesla.
0.35 Tesla. Now, how to find the H from there?
Sir, from BH curve, we will
BH
find
curve.
H
Okay,
new.
what is the materials you consider?
Sir, 0.35
No, what
Tesla.
materials? Is a cast iron steel sheet? What? Which curve? Which curve you consider?
Sir, any curve.
Any curve? No, the
Sir,
curve.
what would be given in the question?
It was not. Okay, let us go. And has seen you. I'm asking you what will be these two value from here. Okay, Tagabun, you can tell me this value. It doesn't require any curve. What is that?
New will be BC new divided by mu naught. 0.35 divided by 4 pi 10 to the power minus 7.
Okay, that one is fine. Okay, what is the answer coming there?
Sir, 278.5.
Okay, HCU is the question. You need the BH curve, and you have a couple of materials curve. Which curve you should? Which one? There are 3 curves there.
Sir, there was something written in the question.
No, but I told in the video lecture that we have to assume this code. The cast iron steel sheet, what I told, remember? No. Good. This is what Modiru Nesa, you don't know, right? You got from the
BH curve.
BH curve. What is that? Can you tell me again? What is the value?
750, sir. 750.
750. What is the unit?
Sir, ampere turn by meter, sir.
Per meter. This
Per
okay.
meter.
Okay. This 750 and this is this. Now this new value HC new and HG new, you have to substitute into the equation in order to check the equation is satisfied or not. Now, Tagabun, can you understand 750 ampere turn per meter? So what is the material? Can you see from the graph paper what material, which curve?
Sir, I can see, sir. 1 minute.
I think you have the curve in front of you.
Yes, sir, I have.
.35 Tesla. Okay, anybody can answer openly. It's no marks. Can anyone tell me?
Sir, it is cast iron.
So yes, sir, cast iron.
Cast iron. So you note it down.
I told you at first cast
Yeah.
iron.
You note, all of you note it down. This is cast iron actually, and that's why 750 ampere turn we got. Now these two values we are going to substitute and get the answer. Lower your hand. Now Takabun got 0.1, no problem. Now all of you please raise your hand, those who can answer to this question next. Okay, all of you, those who raise hand, now I'm going to them. First question to Tagabun again. Okay, Tagabun, yes, you can go ahead, then carry on the rest of the part. What you, if you substitute these two value into the equation, what is the final equation,
yes,
final value coming?
Sir, final value is 398.5.
398.5. Okay, if you 720 and this value you substitute there. Okay, 398.5. Then the percentage you are getting is a negative or positive?
So negative, minus 0.37.
Minus 0.37. Now, is it within the limit?
Yes, sir, it is.
So you got the answer. What is the percentage? 0.37. Takabun,
Yes, sir.
is it the answer and go back home?
No, sir. It
What
is
is the
not the
answer?
answer. The
What is the
answer
answer?
is sir, the phi is the answer.
What is that?
1.05 into 10 to the power minus 3. Phi c
So you
nu
said the phi equal to 1.05
into 10 to the power minus 3.
phi c nu, yeah. Okay, nu into 10 to the power minus 3. Okay, this is the Weber. So your answer is this, not this one. This is the
Yes,
thing
sir.
which is plus minus 5, within plus minus 5% range. If it is, since it is within plus minus 5% range, so you got the value of phi c for which you got this difference is the answer. That is the answer. Your target is to find the phi. Okay, good. I think that is the thing. We can see now next what.
Your hand. What is the answer? Answer is what? 0 point? Tell me, anybody? Minus?
Yes, sir.
What is the answer? Raise your hand first.
So already there is.
You tell me the answer is what? Can you see the whiteboard? I think you can see the whiteboard. I have written the answer. Now you just tell me the answer. That the answer is, raise your hand and tell me. In one shot. Is coming now. There we reduced, we assume 30%. That is a big question. There is a big question. All of you look carefully. Here is the big game in this problem. Instead of 30%, if you consider here, most of you will do what? I'm just telling you. Most of you will do 35%. Most of you. Okay, we can reduce 35%. Or some of you can say, no, I want to reduce 40%. Some of you can say, no, I want to reduce 37.5%. Something like that. Nobody should go for 30% for sure. But you gone for 30%, got the result. But if you go for 30%, 35 or 40 or 37.5, whatever, if you consider, that means you are going to multiply here, 0.3 will be multiplied with just 0.
Okay, hello, Pythagoras, are you there?
Yes, sir.
Okay, if I want to, let's say we want to reduce 37.5%, then what will be the value? Phi nu. Phi nu will be what?
So I'm calculating.
Do it. Okay, you tell me what will be this value we should write. Tell me first.
Sir, what value?
Can you see my cursor?
Yes, sir. It will be you want to reduce by 35%, right?
No, 37.5.
Oh, it will be 0.375.
Tell me the answer. And it
9.
will be multiplied by what? 0. What?
It will be multiplied by.
Means you are not having a calculator in front of you, right?
Sir, I do. It will be 0.625.
And then what is the total value after multiplication? Don't wait. Tell me next
Sir, it
final
will
value.
be 9.375 into 10 to the power minus 4.
5 point.
Sir, 9.375.
Oh, 9 point. Okay. 9.37. Okay. 375, 10 to the power minus
4.
4. Okay. This is what the phi, new phi Weber part. This is the new phi Weber you are getting. And this value give you the BC nu and BG nu, right? That means this value is no more here, rather this 9.375. Can you calculate and tell me how many Tesla you're getting?
So doing that. Sir, it will be 0.312, 0.313 Tesla. 0.313 Tesla.
Okay, all of you agree with this, what he calculated?
Yes, sir.
Yes, sir.
Okay, good. This is the Tesla you get. Now tell me from your graph paper, cast iron, what will be the value? Instead of 750, what will be this value? Tell me. All of you can help actually him. What can be the approximate value?
Sir, it will be around 800.
Is it okay? 800 is close value. Okay, and Prithviraj, if you go for HG new value, what will be the value? It will not be the value.
8G new.
Where is the modification here? Come on.
Only instead of 0.35, we write 0.313.
And then you can find it. What is that? Very simple.
Yes, sir. It's 249077.
249077, right? Now your this value ampere turn, this H value and this H value, you have to substitute into the equation and see whether the equation satisfied or not, right? Equal to 400 or not. And tell me what is that value?
What I'm talking.
Did you could you calculate the value?
Sir, I'm doing it.
It is the value where you have to substitute the HG and HC new. And then what is that final value coming here? Instead of 398, will it be 398 still? Of course not, right?
Yes, sir.
It is not 398. What is the new value?
377.
It is 377. Okay, if it is 377, right? Okay, then what is the percentage of deviation?
So it's minus 6.1.
This is 377 also, remember. Yeah, what is that? Minus
6.1.
6.1% you are getting. Now, Tanvir, are you there?
Yes, sir.
Is it acceptable?
No, sir.
It is not acceptable because it is outside the range, right?
Yes, sir.
Plus 5%.
Consider -5. We should consider
Yeah.
-5.
Now you tell me what should be the next step?
Sir, we put the another value of 5.
Right.
Suppose.
Absolutely another value. We have considered 30%, not 30%. We have considered 37.5%.
Yes, sir.
And we found it is not within the range. So
Yes,
this
sir.
cannot be your answer. You
Yes,
have to
sir.
go for it. So what would be the next you think actually?
Sir,
We assume-
35.
Okay, 35.
No, sir.
Hmm?
Yes, sir. 35.
Next,
If we put
35%.
35. Yes, sir. It is not yet acceptable because it is -8.5.
Oh, you already got.
Yes, sir.
Minus what?
-8.5.
35.
8.5.
35.
For 35%, error percentage is -8.5.
No. It must be in between.
Oh, no, sir.
Right?
Then, sir, yes, sir.
Then, sir, Winston, no, yes, sir. You are just telling me just not the right thing. Tanvi, you are.
Yes.
It is reflecting that you are not genuine. Are you?
Sir,
where do you get the
sir, we
answer?
can-
It is 8.5.
Sir, -6.1 will be acceptable because it is near to -5, right, sir?
No, you try to more divert us.
Oh, sir.
What I am telling you, where you got 8%?
Sir, for 35%.
Yeah,
if
it
we
is
consider.
8%. You told 8%. Where you get it from? Have you done it? No.
Yes, sir.
How come
Yes, sir.
how come it is like that? You try to get my point. 37.5% gives you
Yes, sir.
6.1.
Yes,
and
sir.
30% is giving you 0.37. So 35
Yes, sir.
should be in between, isn't it?
No, sir.
Why not?
Sir, if we calculate, error will be, sir, shown.
Have you done it? Have you done it?
Yes, sir, done it.
Okay, show us.
Sir, just 1 minute.
Okay. If you got 35%, then what is the value you got? The HG value is equal to what? Okay, Tanvir, what is
Sir,
your
check your email, sir. I'll send you.
send it the email.
Yes, sir. Yes, sir. Send.
I haven't get the email yet.
Yes, sir. Now send, sir.
Now you tell me, can you tell me what is your HG value?
Sir, HG value, sir, it is 2.7 into 10 to the power 5.
Okay, let us have a look.
Sir.
HG value is 2 point.
Sir, HG value is 2.59 into 10 to the power 5.
And HC value?
HC value is, sir, it is 750 ampere turn per meter.
Ah, that's it. That is 750 you got for
35%.
30%.
But sir, I think, sir.
I think something wrong there. Okay, now it's all right, no problem. Tashfiqur Rahman, you got any different answer? No, you didn't do.
I didn't do the 35%.
Okay, now let's come back. If you do for 35%, and if you see it is within 5%.
Yes, sir.
Then what will you go for next?
The next I'll take the value of phi, which comes with the 5% error.
You do not go for another trial, right?
No, sir. No,
Good.
sir. Only
What is
two.
that? If it's 35% gives you the answer, it is within plus minus 5%. What is the phi answer? What will be the answer? You said that time we'll take the phi. What will
Yes,
be that
sir.
value? Can you tell me? Phi will be equal to what?
I didn't calculate for the 35% one.
No, you should get and something you have to multiply with 1 minus, what is that?
Oh, for 35%, 1 minus 0.35.
35, right? And okay, fine. And at that time, you are going to write here the phi value. What will be that value?
So 9.75 into 10 to the power minus.
This is the mistake, because
No, the phi value will be original value, sir.
Original, what is that value? I tell me original value.
1.5 into 10 to the power minus.
Right. So what are you talking about?
I told the original.
Okay, I understand it. 1.5 into 10 to the power
minus 3.
Good. This is first value. You have to put minus 3. I'm talking about this value, right?
Yes, sir.
Good. And that will be multiplied by 1 minus 1.05. What is that?
0.65.
Good. Now 0.65. You can easily tell me the answer then.
Yes, sir.
What is that?
9.75 into 10 to the power minus 4.
So this will be your final answer, right? Okay, 10 to the power minus 3. So that's the answer you have to give in the exam and get full marks. This is the Weber answer, because it reaches within plus minus 5% when you got consider where Pythagoras said, I want to reduce 37.5%. After that, he found it is cross 5%, which is 6.1%, right, Pythagoras?
Yes, sir.
It's a minus 6.1%. And then Pythagoras do it for not 37, it is for 35% he got. For example, after considering 35%, it will be based on the original value, this, and she got 9.75 in 10 to the power minus 3. And this value gives him the new HG and new HC prime, these two new values. And after substituting these two values, he got, it is not 9.5, it is not any other value, it is a different value which gives maybe 4.9%, for example, just which is less than 5%. So his answer, Pythagoras' final answer is correct. And if it is within plus 5%, then he can say the answer is now this 9.75%. Remember, it must be based on the original value, as Tarek was telling us. Absolutely, this is correct. It is not the previous value, which is 37.5% given, 9 point something. It should be the original one. I hope that you all understand it. So now we got the answer. Pythagoras said this is the answer, so you get full marks. But Pythagoras, understand what I'm telling?
Yeah, yes, sir.
But if you see, unfortunately, it is not 4.5. It is 5.5 because it was 66.1 for 37.5. For example, just it is now 5.5. Still, it is outside the range, right, Pythagoras?
Yes, sir.
Now you have to go for another trial. Maybe you can go for 30% next. And this way you can go one by one and whole 3 hours exam, 1 hour exam will over and you cannot answer the question. This is never to be happened, remember. All what you have to do after second trial, first trial Pythagoras had gone for 37.5%. Then he could not get the answer. He changed it for 35% second trial, and he found it is still outside the range. If it is still outside the range, Pythagoras, don't go for the third trial. You understand?
Yes, sir.
Even you do not get within the range, you get full marks. You will get full marks if you can decide now what will be the correct answer. Then you get full marks. Out of these two, 37.5 and 35%, you will decide what will be the answer to the question. Now, can you tell me, I am telling you here that it is giving you 5.5 and it is giving you minus 5.5 and it is giving you minus 6.1. You told us already. Now, what will be the answer you should give us in the exam?
The one for the 35%.
Because it is the closest to the 5% range. You understand, Pythagoras?
Yes, sir.
But if you get for 35% gives you, as what Tanvir said, 8.1%. For example,
Sir.
You may get it. Okay, Tanvir, I'm just asking you. Just let's say you got 8.1%. Pythagoras, now can you tell me which one will be the answer?
37.5%.
You get a 0. Answer is 37.5%, is it?
The one that is closest to 5, right?
Right, and that is 37.5% is closest to 5 because this is 6.1 and the other one is 8.1. I agree. But what is your answer I'm talking about? Our target.
The answer is the 5.
Yes, what is that 5 now?
The original 5 into 1 minus 0.375.
You already calculated, you forgot it, right?
Right.
Right, that is the one you have to write the answer, which is neither 9.75 nor 1.5. That will be the answer to the question. Still cannot tell us.
9.375.
Thank you very much for helping us. 9.375. You remember Pythagoras?
Yes, sir.
Into 10 to the power what?
Minus 4.
Minus 4. And Pythagoras, what is the unit?
Weber.
Good. Thank you very much. So this is the way you have to answer in the multiple trial case. Don't go 1,000 times trial. After first trial, second trial, you don't get the answer perfectly, then you can find the closest answer and that will be the answer. You get full marks. Remember, all of you, this is the way you have to answer to this question. All right, thank you very much. I hope that everybody understood it. Now, let us go, and that is the end of this class, and I'm giving you the marks, and after that you can